Hey calculus, we are going to work with differentiable piecewise functions. So the goal is to use limits, one-sided limits, left and right limits, to find the values of the constants a and b. A and b are constants. They are just numbers. And we want to make the function differentiable at x is equal to 2, our dividing point, okay? So the first step, step 1, is to find the left and right limits using the original function. Okay, so I'm going to highlight that, the original function. This is exactly what we did in trimester 1 when we were working with continuous piecewise functions. Okay, so we find the left limit. All right, we use correct calculus notation. The limit as x approaches 2 from the left with a little minus sign up there. All right, what is our left function? Well, less than or equal to 2 is to the left of 2 on a number line. So this is my left function. So I put it right here, ax cubed. Now I have a limit problem and I can do direct substitution. Remember, we put 2 in for x. So we have a times 2 cubed. 2 cubed is 8, so that gives me 8a. That is my left limit of my original function. Now I find my right limit. All right, so I have the limit as x approaches 2 with a little plus sign for correct notation. Up here, this branch is our right function because it is greater than 2. Greater than 2 is to the right of 2 on a number line. So I plug that in right here. The limit as x approaches 2 from the right of b times x minus 3 squared plus 10. Now remember, I plug in 2 for x. So I have b times 2 minus 3 squared plus 10. Now I just go to work. Inside parentheses gives me a negative 1. Negative 1 squared gives me 1, so this just gives me 1 times b, which is b, so this simplifies to b plus 10. And that is my right limit. Now, in order for the limit to exist, the left and the rights have to be the same. So the final step here is to set my left limit equal to my right limit. So I have 8a is equal to b plus 10. Okay, now that obviously isn't enough to find a and b, but I haven't done anything with this word differentiable. Differentiable means take the derivative. So that's my second step. I do the same thing. I find the left and right limits, but now I use my derivative function, f prime of x. So let's try that. The limit as x approaches 2 from the left, the derivative of my left function using the power rule, 3 times a gives me 3a, and then it's x to the second. I subtract 1 from my exponent. So the derivative of ax cubed using the power rule is 3ax squared. Now I have a limit problem and I can do direct substitution. Remember, you plug in 2 for x. So I have 3a times 2 squared. All right. 2 squared gives me 4. 4 times 3 gives me 12. So my left limit simplifies to 12a. All right, now we do the right limit. The limit as x approaches 2 from the right, but I need the derivative of this function up here. So b is a constant, a number out front. That comes along for the ride. All right, now for this part right here, that is a chain rule. Okay, the outer function is something squared, and the inner function is x minus 3. So the derivative of the outer, right here after the b, is going to be 2 times something to the first. The inner as is going to be x minus 3, and the derivative of the inner function is just 1. The derivative of x is 1, and the derivative of negative 3 is 0. So that just gives me a 1. So my derivative simplifies to 2b times x minus 3. Now I have a limit problem and I can do direct substitution. Remember, I put the 2 in for x. So I have 2b times 2 minus 3. If I simplify inside parentheses, I get a negative 1. So that simplifies to negative 2b. That is my right limit. Now, in order for the limit to exist, the left and the rights have to be equal to each other. So I take my left limit, 12a, and I set it equal to negative 2b. There is my equation for my derivative function limits. Okay, the third step is to take these two equations, the equations from our original function, left limit and right limit, and my derivative, left limit and right limit, and solve for a and b. Now it's all algebra. We have a systems of equations. There's a lot of different ways to go about solving this. I'm going to do this. I'm going to go over to this equation, and I'm going to solve for b. All right, so I'm going to take this and solve for b. So that means I just divide by negative 2. All right, so I'm going to divide this side by negative 2, and I'm going to divide this side by negative 2. These cancel out. My b is equal to negative 6a. All right, so I'm going to be coming back to that. But now, because b is equal to this, I can take this and plug it in right there. So I'm going to rewrite this equation, and I'm going to plug in what I know b to be. So 8a is equal to b. b is equal to negative 6a. So I'm going to plug that in right here. Negative 6a plus 10. Now I have an equation with one variable in it, and now I can solve this for a. Again, this is all algebra. So I am going to add 6a to both sides. On the left, I have 14a, and on the right, I have 10. Now I just need to divide by 14. So a is equal to 10/14. Or you could reduce it to 5/7. Or if you don't like fractions, you could get the decimal. 0.714. So I have a. I'm halfway done. Now, the easiest way to get b is to go up to this equation right here. So I'm going to bring it down here. I'm just going to rewrite it. Negative 6a is equal to b. So now I can take my a, whichever one of these choices you like best, and plug it in right here and solve for b. All right, I'm going to use 5/7. I'm going to take 5/7 and plug it in right here. So I'm going to make 6 a fraction, negative 6/1, times 5/7 is equal to b. So now my b is equal to negative 30/7. All right, or if you don't like the fraction, make it a decimal. Negative 4.29. Okay, so there you have it. I have my a right here, and I have my b right here. Okay, again, let's just walk through the steps again. The first step, we found the left and right limits of our original function. Left limit was 8a, right limit was b plus 10, and we set them equal. All right, second step, we found the left and right limits of our derivative function. So we found the derivative functions, 3ax squared, that limit was 12a. We found our right derivative, 2b times x minus 10, and that limit was negative 2b, and we set them equal to each other. Then we took those two equations and we've solved for a and b using algebra. And again, for that third step, there'll always be more than one way to do it. All right, thanks calculus. Go ahead and try the piecewise functions on your homework worksheet.